Good morning, class. Today, we will illustrate the concept of the impulse of the pimp slap. We will account for 4 things: mass, velocity, force, and time. Now, let's see this in action.
Why does you always talking about Cracker Barrel when you go to class?
Man, I don't know, man. It's like you come to class hungry every single
Bro, he always come in
day.
What? Yeah, I did.
Why you out?
Today we're going to be talking about the impulse of the pimp slap. And when speaking about the impulse, let's first take into consideration the force. As we can see, the force is equal to the mass times the acceleration. But in narrowing down the acceleration and trying to get terms of impulse, we want to change the acceleration into terms of velocity. So, in looking at this equation right here, we get force is equal to mass times the final velocity minus the initial velocity. And we can see that the final velocity is denoted as v2, while the initial velocity is denoted as v1, divided by the change in t. And so, in looking at that, we can distribute the masses for each of the velocities that we wrote. And we have force is equal to the mass of the final velocity minus the mass of the initial velocity divided by the change in t. And this goes down and simplifies to force is equal to the change in p divided by the change in t. And when we look at change in p is called momentum. T is called the time. If we multiply each side by the change in t, we get force times the change in time is equal to the change in momentum. And this is very important when talking about the concept of a pimp slap, because of the simple fact that when initiating a pimp slap, the mass is a factor taken in that instance. We have the mass, we have the acceleration, we have the change in time, and the change in momentum. And this is very important when talking about the concept of a pimp slap, because of the simple fact that when initiating a pimp slap, the mass is a factor taken in that instance. We have the mass, we have the acceleration, we have the change in time, and we have the change in p. Considering that the momentum is constant, if we were to increase the force applied, then we would have to decrease the time to maintain the same momentum. A momentum remaining constant, if we were to decrease the time applied for the pimp slap, we would have to increase the force exerted to maintain constant momentum.
So in conclusion, be mindful of where you are and what you're doing. The pimp slap can happen to anyone. Are you ready for it?
I got my icy, son.